is exponential functions. Have you heard of a viral video? Something go viral on YouTube or TikTok and whatnot. What does that mean? Yeah, there's a lot of views, right? So if something go viral, it means it grow exponentially, right? So all of a sudden overnight, it's just number of viewers just shoot up. Right? So it's grow very fast. So it's kind of characteristic of exponential functions, right? In fact, in our daily life, you see a lot of exponential functions, right? For example, radioactive decaying, right? It's decaying at it's followed the rate of decay is following exponential function, right? It's decaying really fast. Or maybe happier events. You don't want radioactive in your system. Money, right? If you have a lot of money in the bank and you invest it, then you make money on top of money on top of money. And at some point, that money grow a lot, and you put all of that, invest it again. You're gonna grow a lot, like exponentially. So that's called compound interest. That's why you start your retirement right now. Later, I'm gonna show you a little video. It's pretty cool. That guy do with the dominoes. Just remind me if I forgot. Or bacteria, right? Grow exponentially, right? When you get sick really quick because those bacteria multiply exponentially. Not everything grow linearly. That's simple. Okay. Oh, I don't want this. This is from the morning. What did I do? I wrote here. I wrote here too. Oh, I wrote here too. Why do I wrote both? No, I can't do both. No. Hang on. Yeah, give me a second. Yeah, I need to hold on, give me a second. So I have a new PDF file. Come on. There you go. Yes, gone. All right, I just have to knit it. All right, so here's the exponential function looks like is y equal b to the x, where b has to be positive and not equal to 1. Well, makes sense, right? You don't want b equal to 1. 1 to any power is 1. It's a flat line, right? It's not dramatic. We want dramatic, right? So that x can be anything really, right? That being said, that being those rules, let's see which function below is the exponential functions. Y equal 3x squared. Is that an exponential function? But by the way, when you look at the exponential function, what is different? What we've been studying so far. Where's your variable? It's on the power, right? So let me ask you again: is y equal 3x squared is the exponential function? No. What kind of function is that? Okay, it's not wrong, but more specific. Binomial. More specific. What is that? You wasn't raise your hand. You did your exam. What is that? The good old quadratic, right? You know it, you love it, right? 3x squared, right? This is a good old quadratic. So nope. It's a polynomial or monomial. Let's just say a quadratic to be exact. It's quadratic function. Y equal 1 to the x. Y is no. That's all right. By the way, this is your chance of bonus check mark, right? Y is no. Yeah, b cannot equal to 1, right? This is just equal 1. It's boring. So nope. So Mizano line y equal 1. What about the third one? Y equal -2 to the x inside parentheses. No, because why? Yeah, because b is negative, right? Remember, b has to be what? Positive, right? By the way, this is not even a real function. If I put x equal 1/2, what another way of saying 1/2? How? Square root. What's square root of -2? Yeah, complex, right? Complex number. That's I square root of 2. Square root of -1 is I, so factor it out. So, so you can even graph this on decimals or your graphing calculator if you haven't changed the mode. So nope, it's complex, which we're not going to talk about right now. It's actually very cool. One of those days, I'm going to show you how to the graph of the complex functions. They're very cool. They're pretty. They're very pretty. You can make it yourself too. I'll show you some code. What about? Oh wow, you're not in good shape. Oh, so none of them is exponential function. What about this one? 4. Why? Oh, okay. Yes, you're right, but not right. I say it is. Why? What's the difference between number 3 and number 4? Yeah, the only thing different is parentheses, but why so critical? Can someone rewrite this for me? Rewrite this. Very good. -1 times what? 2 to the x, right? Now here the x applied for the base, which is -2. Therefore, our rule here the x does not apply for the -1, right? So basically, you can graph this function, and all you do is just flip it over the x-axis. Then you got it. Right? So it's the exponential function. It's b is positive, it's not equal to 1. So yes. Y equal 2 to the x. Oh, definitely yes, right? It's a good old classic exponential function. The first thing any professor teach you about exponential function, this one they show you first, and I'm going to do the same. So yes. Y equal 1/4 to the x. Like, oh man, is there anything wrong with it? So you say yes, it's an exponential function. All right. Anybody else have different opinions? Yeah. Why is that? Yeah, it's not negative. It's between well, it may be what? It's maybe less than 1, but it's not 1, so I'm good, right? So by the way, let me maybe do this for you. Here's the number line. Here is 0. Here is 1. Can't be 1. I don't want 1, right? That I don't want anything from what? Anything less than 0 either. Right? Can I get 0? Yes, I can get 0. No, I don't want 0 either, because 0 to the x is 0. Y equals 0. I just x-axis. So what do I want? I want what? D2, right? Either between 0 and 1 or bigger than 1. Right? So yeah, 1/4 is okay because between 0 and 1. This is called exponential decay. Number 5, exponential growth. 7, last one. Is this an exponential function? Is anything wrong with it? Let's check. Is B okay? Yeah. What about X? Is X okay? Did I have any restriction on X? No, I said X can be anything, right? As long as B is positive, that one. X can be anything. One more question. Is this any way that it's a negative number? If I plug in any number class, any at all, give me one. Is it ever going to turn out to be negative? Is there any X that you choose that make that function negative? No, right? Because how do I rewrite this? Very good, right? And it's still positive, so 1/3 to the X. You pick X negative, it's still positive. So on the exam, this is the way that I'm gonna give it to you. You're supposed to understand this like this. I never write like this. I like it like this. First of all, shorter. One-third between 0 and 1. So we good. All right, so now you know which one is exponential function and which one is not. Okay, so remember, I told you there are 2 cases. One is between 0 and 1. This is called decay, exponential decay. And if it's bigger than 1, if the base is bigger than 1, it's called exponential growth. It's something like your stock or your investment, hopefully. Right? Hopefully. Oh, let me show you a video, pretty cool video. I stole it from one of my colleagues. Well, borrow without permission, I guess. Check this out.
How much money do you have in your pocket right now? I have $40. 21? Could something that small make an impact on something as big as your retirement? Oh. Well, if you start putting that money towards your retirement, 30 years, that retirement challenge seems so big after all.
That's the power of compound interest. Let your money make money. Right? So start your investment right now. Right? It doesn't have to be a lot. Just a few hundred per month, or just 100. And of course, it's gonna go up and down depending on the economy. But historically, over time, it will grow. Right? Less or more, it will grow. That's why rich people get richer. So they have money to invest, and that money is compounding. Go back. Okay, so have you seen that domino? What's the shape of it? It's like a curve, right? Like a curve. So we're gonna try to graph it. Start with y equal 2 to the n. Like I said, the classic exponential function. B is bigger than 1, so we're gonna call it exponential growth. And you see y growth. Now, if you don't know anything at all, if I ask you to graph something funky looking, what's the first thing you do? The table, right? Like I'll plot my points. I can't get wrong with that. And no, you don't get wrong with it. I still have to give you credit, even though you don't know anything. Because you're not wrong. It's just you don't do the way I want it to. You wasn't wrong. All right, so let's plot some point. X, y equal 2 to the x. I'll pick -4. No, -2, too big. -2, -1, 0, 2, 1. when x equal -2, what's y equal? 2 to the -2 is what? 1/4. Very good. 2 to the -1 is 1/2. 2 to the 0 is 1. Yay. I'm gonna do, you want blue because I want to report. And 2 is 4 to the first 2. All right, I think we're good. Okay, here's y, here's x. What do I want? What do I want? I want the x is between -2 and 2. Just put some tick mark here. The y is go from 0 to 4. 1, 2, 3, 4. And then here is 1/2. Here is 1/4. All right. Okay. -2 is 1/4. So tiny dot right here. -1 is half. Still slightly higher. 0 is 1. 1 is 2. Yeah. Oh, I don't know why I put this 2. I wanted 2. 1, 2. You don't have to fix it. And 2 is 4. Connect the dot. You see the same shape that you see in the dominoes videos, right? Please do not pass. Do not pass. Go through the x-axis. If you can avoid touching it, would be great too. But yeah, the least you can do not pass it. I'll tell you. All right. Now, the reason I don't let you pass the red graph, not pass the x-axis, because it's called the horizontal asymptote. How do I determine that? Well, if you look at the function, you look at the number next to the function. Is there anything next to the x? No. So I can just say what, 0, right? So I can just put like +0 here, and that will determine your horizontal asymptote. So this 0 here is HA, horizontal asymptote, which is y equals 0. You won't see it when you graph it, but your graph will never touch it. Right? It's kind of like vertical asymptote. It depends. If you have something need to add to or subtract to the function, say I say +1 here, then your horizontal asymptote shift up 1 unit. But if it's -3, it shift down 3 units. By the way, start from the blue dot. That's why I put a different color. It's important. Everything start from there. Okay. But we'll talk about that later. The domain. What's the domain of this function? Very good. On the exam, everybody got, I think like 95% who got the correct domain range. I'm very happy. Range. Very good. Like I said, we don't touch x-axis, so we don't include 0. And then the horizontal asymptote, y equals 0. And the blue point there, maybe label it 0, 1. Because later I'm going to show you a thing called transformation. You're going to shift. Gotta say it right, shift. You good? You guys good? Yeah. Let's grab the second case. Do the same thing, right? I don't know. I want to do it by hand or by. I write this because the same thing is the same thing. Decimals. Oh, here. Let me show you to do something. I'll show you how to do on your graphing calculator. So take your graphing calculator out. Y equal. The second one, y equal 2 to the negative x. So 2 to the negative x. Everybody okay with that? Oh, sorry. Your calculator. 2 to the negative x. So you have to do by hand. I want table. Now, before the table, I need to see my table set. Second window to go to table set. Second window. You want independent to be asked, dependent to be auto, and leave it for the rest of your life. Because you plug in X and spit out Y. Right. Now go second graph to go to table, second graph. Right there. If you don't have anything yet, just plug it in, -2. Should spit out 4. You can do this on the exam if you want to.
So independent ask.
Independent is ask. Dependent is auto. Yeah. Okay, so you can fill in the table. That's why I don't want to feel like doing it. Maybe I should. So because I want to graph it. We have time. No issue. Yes. I have it because in the morning I punch it in.
Yeah.
But yeah, you're right. You're on the right. You can do it yourself.
Yeah.
You don't see anything yet, just punch in the number for X. In the meantime, I'm gonna do this so you have your note. X and Y. Again, I picked -2, -1, 0. Ooh, 0, 1. I'm gonna use blue. 1. When X equal -2, Y is 4. 2, 1. 1/2. 1/4. It's kind of opposite for the other one. Oh, but by the way, let me go back up here. It's exponential growth because from left to right, your graph what? Increasing, right? See what happened to this one. On the exam, I'll give you the graph, of course. -2, 4. 1, 2, 3, 4. 1/2, 1/4. -1, -2, +1, +2. Okay, all right. -2 is 4. -1 is 2. 1 is, well, 0 is 1. 1 is 1/2. And 2 is, oh, by the way, if you hit the graph, it'll graph it for you on your calculator. You want to do by hand. Again, don't touch the x-axis. That's your horizontal asymptote. Because nothing next to the function. This is plus 0 here. So y equals 0. Domain. Yeah. Range. Yeah. And then so. By the way, it's not always like this, okay? It's every graph is different. Depend how much you add it to the function. This is simple. Sometimes it's more elaborate. I don't know why I have it there. I don't know why I have it up there. I want to do this first. Skip that one. I got a job for you. I want you to graph these. There are 2 sets. One is the exponential growth. And the other one is exponential decay. So graph those. When you're graphing calculator, see what happens. You tell me what happened. If you have questions, please let me know about the calculator.
No, no, I'm always like, see you.
Well, practice your calculator. That's what allow on the exam. I want you to graph it. Do not do the table. I just want to see the graphs.
I don't know what that is.
Oh, yeah. Cursor also flat.
There you go. Thank you. Thank you.
Nice calculator. Show color.
Apparently, I don't know what that is. Thank you.
Very good. Good job. What do you guys see? Is there anything you tell me? Is there at least one characteristic you see in there? Yeah, which point?
What?
Letter 0, 1, right? 0, 1, yeah. So practice your calculator. I know I use decimals, but because I'm a teacher, I'm not taking an exam. You guys are. Here I put it here in my decimal. Y equal 2 to the x. I'm gonna put that point there. Y equal 3 to the x. It still go through the same point. 5 to the x, even 100 to the x. So it's the same graph, it's go to the same point. What's the difference between these graphs? As you increase your base, what happened? It get what? It gets steeper, right? It gets steeper. It grows faster. It grows faster. So that's all it is. That's all it is. If you increase your base, it just grow faster. But it always go through the point 0, 1. Right? Assume that you don't add anything to x. You don't add anything to the whole function. All right. So let me mute that and then do the decay one. Same thing, right? If I increase my base, let me do it again. So here, choose the negative x. Like that. Negative x. Yeah. And still go through 0, 1. 3 is the negative x. Look at that. 3 negative x. Is decreasing what? Faster or slower? Faster, right? It's base bigger, decrease faster. 5 to the x. And they're all the same thing. They all go through 0, 1 again, even with the decaying one. Right? It's a nice symmetric one. That's why the point is very important. Now, later I'm going to show you how to shift these, starting with 0, 1. You don't start with the origin. So for example, if I add 3 here, like 2 to the x plus 3, we mute all of these. Say this one I put like this. But let me ask a question. You think it's gonna move right? It's gonna shift right or shift left if I add 3? Yeah, naturally it's supposed to shift right? But no, it's shift left. It's shift left. So it go from 0, 1 to what? 3 units to the left will be what? Negative 3, 1. Right there. You won't let me. Anyway, right there. So it shift left. Always you start at that 0, 1. You don't start at origin. You just kind of shift the whole thing, copy and paste. It's the new location. That's all. Now, if I add thing, I want to shift vertical. So that's the horizontal. I just kind of shift sideways. If I do vertical, see what I can. If I plus 2 here, you think gonna shift up or shift down? Up, right? Pretty straightforward for the vertical shift. It's up. So from it was negative 3, 1 was it? Yeah, it was negative 3, 1, but it go up to what? 2 more units. So from here, 2 more units. So what is that? 3, right? Negative 3, 3. So now you go to negative 3, 3, right there. But that's your new 0, 1. So one thing I get out from here is that for the horizontal shift, you look at the power, whatever being attached to the power, that's going to be shift sideways, right? If it plus, you're going to shift to the left. I know it's kind of counterintuitive. If it plus, you shift to the left. If it's minus 3, you shift to the right. It's opposite to what you see. But for the vertical shift, up and down, it's pretty straightforward. Add, go up, minus, go down. The reason being in this one is because the formula is 2 to the x minus k plus h. Right, so we're almost done. I'll let you go early. We're almost done. Let's go back to this one. Do I shift to the right or shift left? To the right, right? I know it's weird, but it's shift right. So this one right here. Shift right 3, right? The reason being because the formulas look like this. It's y equal b to the x minus h. H come first, right? And then plus k. So so if you have don't write this down. If you have y equal 2 to the x plus 3, it's actually what? Y equal 2 to the x minus 3. That's why you shift left. Right? That's why you shift left. So I guess it's not very, very counterintuitive. The reason being because of the formula. All right, that's it. We're gonna continue next time because I stop right here in the morning as well. Monday, finish 3.1 quiz, and then you can leave. Right? I'll let you know. All right, have a good one. Michigan win, you win.